Welcome back, everybody. The breakout rooms are officially closed. It is time for our EV Day wrap up. I hope you all are ready. I know Milton is ready, and I hear that a lot of you are ready at those schools. So teachers, turn on your cameras. We want to see what you all have created. And Milton, are you ready?
Hey, I'm ready to go. Let's do this.
Let's
Welcome back
go.
to EV Day. This is such an exciting time. It's been a really, really great day. You all have been kicking butt and doing this thing. Before we jump into the presentation, I want to give a huge shout out to the ET team. Having a day like this, there's a lot of moving parts. So shout out to Brianna and Harper and Elaine and Grace and Morgan, but everybody else, Betsy, Carly, Monica, Constance, Megan, our entire team here. And Jillian has been kicking butt, snacking all these pictures for me today. I mean, it's just been unbelievable. I know you really enjoyed the presentation by Harper and Elena, and we did something extraordinary today, right, Constance? Constance told the engineers to go out there into the streets, into the schools, and take over, man. They are live in schools today. Maybe we'll do this every special lab day. Maybe we're coming to a school near you, who knows? But Joanna, Eric, and Jerry, we're gonna just capture them live at some point today. So this is your time. This is our EV wrap up. And like Monica says, you're the star of today. You all have been kicking butt and taking names, the engineering prowess that you've demonstrated, the teamwork, the awesome EV vehicles. I mean, you see the claps and the cheers. I mean, you all were designing all throughout the day, and you created some really, really great vehicles. We saw propulsion-based vehicles. You see a pulley design, which is really, really awesome, Monica. We saw a little race, right? Even a race that involved some humps and bumps trying to get between those different tables. And then finally, we just saw your final products. So what we want to do here today in our wrap-up session is we want you all to engage some. And remember what we talked about this morning. Hey, what would this world be without transportation? So important, to be able to have vehicles that transport us from across the world. Well, I am Milton Davis, and what I do is I develop electric vehicles as well. They're satellites. It all started for me with developing an electric vehicle called an RC car. And I love me some RC cars, right, Monica? You put that together with a little space, and I figured it out. I landed on aerospace. I've been working at NASA since 2001. Don't count the numbers and try to get my age. That's mean. I went to Purdue where I got a bachelor's in aerospace and aeronautical engineering, and that is me as an intern. Kelsey today, our awesome speaker, is going to talk about internships. We'll highlight internships as well. And what I'm working on right now, actually, we're kicking and screaming, trying to keep this project going. It's called OSAM One. Our electric vehicle is going to build robots in space. We're using robots to build assemblies in space. So we are really excited about that. And now, without further ado, it's your time. It's time, Monica. We want you all to just show off, right? Ricky and Bobby, the Ricky Bobby team out there, we want you to show off those vehicles. We want to see those designs come to life. So I'm going to stop sharing. And this is all we want you to do. Show your vehicle. Even if you just show your design, that's fine. If it doesn't work, if you want to show how you came up with your cost analysis, that's fine with us. Whatever you want to show, just show it off. And I'll stop sharing.
All right. I see a lot of cameras are on, but I don't see a group that's ready. If somebody could use their Zoom and raise their hand so we can spotlight you and show what you're doing. I see Joanna in the camera there. Joanna, are you ready? Do you want to unmute and chat with us?
Nice.
Let me spotlight Joanna Cotto, who is a Jackson Reed.
Hey. Oh, I think I got it. Okay.
Yeah, we can hear you.
You can hear me great. Hey, everybody. We're here at Jackson Reed, and we're just eating some pizza, trying to finish up. We got a little bit of a later start, but I can't tell you how amazing these students are. I've had some great conversations. They have an amazing program here where they are doing digital electronics. Here's Mr. Ghosh. He can tell you a little bit about his class. Yeah.
Okay. Hi, everyone. This is Mr. Ghosh. So at Jackson Reed, we have different kinds of pathway, including engineering pathway. I teach a couple of classes for engineering. And as a part of my digital electronics, we took this lab, and I'm doing it for a couple of years now. And it's more related with the curriculum that I'm teaching, and student loves it, and they enjoy the whole WBL or work-based learning activity throughout the day whenever we do this electric vehicle challenge. on top of it, they also feel interested for our electric vehicle club because we do have a club as well.
Ooh.
And we
Milton, I knew
regularly
you'd love that.
participated in DC local event as well as this year kids went to Abu Dhabi to explore like the Grand Peaks over there. So I would like to call some of the kids to share their ideas
Yeah.
and experience.
Call them up. You know, I don't know if I'd rather take that slice of pizza or you show me off that electric vehicle that's over there to the left, man. It's a tough choice, Monica. I don't know. I'm starving. That pizza looks great, Joanna. Sheesh.
What do we do?
Can you tell a little
Like
bit
talk
about
about
it?
your experience with
Yeah, show your electric vehicle. Yeah, talk
you
about
show
some
the-
challenges you overcame, you know.
No,
Grab that car, grab a car. Let's see it.
Yeah.
It's okay. It's okay if it doesn't work. That's all good, you know.
Maybe it's a bit boxed up right now.
Yeah.
I thought we were gonna talk.
Can you guys a little
Okay,
bit-
Yeah,
back up.
Can you show them your electric vehicle there? Let me see here. Let's see.
Okay, so
We have built like a full-size electric vehicle that can fit
Ooh.
just an actual person inside of it.
Okay.
Oh man,
So it's right
Oh.
there in the back of the room.
what?
I'm not sure if you can see it. It's
I
kind
can
of
see it.
you can I mean for
Wow, look at that aerodynamic design. Sheesh.
yeah
Man.
this one and I'll connect that one then.
so we have 3 of these cars. We
Wow.
recently a new one this year, but it's a fully electric vehicle and you can fully fit inside of it. One person, one driver. We compete in the DC area and we went to Abu Dhabi to compete again. It's a lot of fun to build the car and actually experience the electric vehicles. I'm not sure what else to talk about.
That's
Any
great.
other points?
Thank you so much for showing that.
So who it can be any kid that can drive. We usually select the driver just based on time trials that we run around our track at our school. But that's about it.
Excellent. Look at that. You know, you take this little EV and you all could be like this school at Ramat Gash and build an entire electric vehicle. That was wonderful, man. Great job. Do you have a little EV to show us off as well? Show us a little EV you all are working on.
Sure, we're still working on it, but
That's all good. Hey, if you're not finished, it's fine.
here's the base, the frame, and the
Ooh, I
batteries.
like that. Look at that. Now, you put the small gear on the motor and the large gear on the axle. Do you know why did you all do that?
This is another group's. I would do the opposite, put the large gear on the motor and the small gear on the axle just to get more speed. But I believe they wanted more torque, so
Dude, you're a genius, bro. I can tell you know about mechanical advantage. But I like that design because I think that car is so heavy, they need to gear up. So I think they're kicking butt. But that's a clean design, man. I like it. I think it's gonna work really well. We have to come back to you all once you get that working for sure. Excellent job. Excellent. Very nice.
no problem.
Yeah.
Who's up
thank you
next?
all. Thank you all.
Thanks, Joanna. Live from Ramen. Gosh, man, that was great.
Jackson
I'm
Reed.
jealous.
That's Jackson Reed in Washington,
Jackson Reed.
D.C. Yes.
Yeah, help me clean that up, Monica. Jackson Reed. That's right.
All right. I don't see any raised hands. I see a lot of groups ready. Oh, I see one in Kevin Williams' class. Are you guys ready?
Yeah, you
All
all
right.
were so hyped in the chat. Nice. Hey, how's
Hey.
it going? Let's do it. Who's coming? Who's gonna look at those cars? I can see 2 of them already. Let's do it.
Can
Come
we show
on
the
up.
cars to the camera, please?
You see the car with the wings?
I see it.
You
I see
that,
it.
Monica?
Can you grab it? It's behind you on the. Oh, she has it.
Oh,
Very nice.
nice.
Hold it up again. Hold it up again so we can see it.
Nice. Yeah. Can we see it from the bottom? Turn it over. I want to see it from the bottom. Oh, look at those straws. Look at those straws. Nice. That design is so clean. Yeah. Can you talk to us about it? Like, what inspired you to come up with this great electric vehicle?
I don't really know. It just popped up in our head.
Okay. Hey, does it move? Is it able to move? Can you give us a little test run?
Yeah.
All right, on the table. On the table, we can see that would be great. On the table. Yeah, that's right. Make a little space. That's right. All right. All right. There you go. Set it up. Man, they have some great energy. Nice. Excellent. Look at that thing moving. That's fast.
Turn on my.
Oh, Monica. Great design. Wow. Wow. Wow.
Thank
Wow.
you.
Nice.
Thank you.
Excellent. Great job. Is that Carver? Great job, Carver.
We have somebody else from Carver in another classroom that has their hand raised. In addition to Carver, any other school, please raise your hand so we can see what's going on. Ms. Hernandez class, here we are. You guys had your hand raised.
Hey, how's it going?
Challenge prep, you'll be next.
Come on, who's coming? Who's going to talk about the design? Let's do it. Who's coming up?
Can you hear them?
This is Carver Middle School, and no, Janelle, tell us about your homie design.
We can hear you.
Yeah. No, come on up here. Come on up here.
Yeah. Maybe you're not quite ready. We
All
want
right,
to come
we'll
back
come
and
back.
highlight another school. We'll be right back for you all once you
Challenge
all get
prep.
seems like they're
Challenge
figuring it
prep
out.
told me that they were ready, but I don't see their cameras. Where's, oh, there they are. Challenge prep, here we go.
All right. All right.
Okay. Okay, so this is challenge prep. Pretty wanted to show her design.
Mine is the wind turbine.
Mm.
At first it didn't work because I had used the pack that only had one battery, but I changed it to the one with two batteries,
Okay.
and now it actually moves.
Wow. Man, I love that. You talked about a challenge. You talked about how you overcame that challenge. So are we going to get a demo? I love the artistry too. I like the yellow housing. Can we get a demo? Can you show us how it moves?
Okay.
Oh, nice. I can hear it. I can hear that fan moving. It's moving. There it goes. Wow. Nice. Excellent. Great job. Are we 3 for 3, Monica? Are we 3 for 3?
We are.
Excellent.
This is
Oh,
fantastic
nice
job, challenge
I
prep.
agree.
Yes.
Great job.
Oh, there it is.
Still going on the rug. That's nice.
All right, did anybody else want to share real quick?
Okay, we see some hands that are raised. Great job. Challenge prep.
They're gonna come back to us.
Do we have another group that's ready at challenge prep before we go off?
Oh, Amelia, are you still?
We
ready?
have one more.
One more.
Okay.
All right, let's
Okay.
go.
Okay, mine, I have the problem of this because if I put it down, it will just go for some reason. So then I use another one for this one. I'll try if it's going or not. We'll try, we'll see.
All right, we'll
Okay.
All right,
test it
let's
out.
see. We're gonna test it.
It's a pulley
Love this.
design. Pulley design.
The wheel.
There
Yeah.
it is.
I love the courage, Monica. Let's just have at it.
I
Let's
heard
see.
the motor running when she had it in the air. Let's see.
Oh, there it goes. It was going.
Give it a little push.
Oh, great. Oh, that's excellent. Very nice. Great job. Right.
Thank you so
Excellent.
much, challenge prep.
Yeah.
All right,
Oh,
we
yeah.
have Southwest ready. Let's spotlight them.
Hey, how's it going?
Okay, this okay, she's introducing herself.
We can hear you now.
My name is Savannah J. Vanderbosch, and I built this mobile car. This Team 12 on it,
Called a what?
and it's electric car.
Okay. So now you got to
Nice.
demonstrate.
We see the bottom
Show them
design.
how
That's
it's-
great. We're
Right.
highlighting Southwestern Classical Academy.
Right.
Everyone else, if you could please ensure you're on mute. We want
One,
to make sure this team gets the
4,
opportunity.
6, 7, 8,
Countdown.
9, 10, 11, 12.
Oh,
Whoa! Not uh-oh. Good catch. Great.
You want
Great
to
car.
turn it back?
Very nice. Yeah,
Very nice.
very nice.
Good
Great.
job,
It goes
Savannah.
really straight too.
All
Yeah, it
right.
is.
Thank you.
Great
Excellent
job.
design. Okay. Okay. Great, great, great. And I love you all have your hands raised. Yeah, we're doing this really, really nice. Very nice.
All
Excellent.
right.
Who's next?
I see a lot of excited. Just when we get to you guys, if you guys could just lower the volume because we cannot hear you when you guys are all screaming. I'm gonna spotlight. I don't know what this one with their hands raised. These young ladies. Hi everybody.
Spasto.
I didn't want to butcher it.
Hi guys.
Hey,
Okay, so we have this. It is it's like
Ka-chow.
McQueen themed and it's gear powered. Yeah.
Very nice. Hey, can you turn it to the side so we can see the gears? I love the cover, man. That's really great. You got some aerodynamics going. Oh, I see the gear. That's nice. Just one battery. Just one battery. That's nice. Look at the efficiency.
We tried to use 2 batteries, but it was like too much weight, I think. It like powered it. Yeah, it was overpowered. Yeah, it was so overpowered. It wouldn't move.
That's a beautiful design. Can we have a demo?
Yeah. Okay.
Cool.
Okay. Wait, ready? Wait, we have to connect it to. Here, do you want me to do it? And then. Okay. Ready? Ready? Wait. Oh wait, it's gonna go the wrong way. Okay, ready? Oh wait, wait.
Oh,
2, 1.
oh, that's nice. It's so fast.
He's
It's so
fast. Lightning McQueen
straight.
is fast. Yes.
It's so straight. Sheesh.
Great job.
Thank
Very
you.
nice.
Great job, team. All right, we
Excellent.
have our next team that's ready to share from St. Barnabas High School. I'm going to spotlight you. If you guys can unmute. Oh, somebody's sharing their screen. All right, Barnabas. You guys can unmute.
Hey, I used to watch
Don't be
them.
shy.
Hey, how's it going? Friends was one of my favorite shows. I got to say that.
I'm with you.
Okay, nice
All right,
design.
ladies.
Talk to us.
Okay, this is our creation. So at first, what we did was we put the wheels on the actual body first, but we found out that it was too low to the ground and it was stopping it from moving. So we added sticks together to kind of levitate it so that it can move more quickly.
Excellent. I love the troubleshooting.
Okay. Hold on. You see?
Nice.
Yes.
Excellent. Great design.
Fantastic.
Did you have to remove any materials to make it lightweight? Like, did you have to remove things to make it lightweight?
No, we had to add things so that we had to add this so that it can actually move because
Great.
when the fan was close to the bottom, it stopped it from moving.
Oh, okay. Got it. Excellent. Very nice.
Well,
great job.
Thank you.
Thank you so much, St. Barnabas. We are going to
Barnabas.
Jerry Dawes, who is ready with us at Salesian. So let's go.
G-Dawes.
There he is.
There he is.
There he is. You got to unmute.
ET engineer G-Dawes.
Are we ready to go?
Yep,
You're
we're ready.
Ready to go?
That's right. Race time. Let's do it.
Okay, hello everyone. Jerry Dawes, one of the ET staff engineers here. We're at Salesian High School, New Rochelle, New York. I want to introduce our teacher first, Ms. Maria Gomez Vatero.
I teach computer science and we also have a robotics team here. Here is Richard, who used to be in robotics, and he's gonna show off his car.
Excellent.
Go ahead, Richard.
Show the design first.
All right, as you can see,
A little bit down, right
as
there.
you can see, I added the 4 wheels and the bottle cap was necessary, so I was able to attach the fan while also carrying the batteries to add a little bit more weight. Yeah.
Hey, that car is super long. Why did you make it so long? What was your thought?
Oh yeah, it was a running joke. As soon as it says, "Hey, let's make a foot long," it was a Subway reference. Yeah, we just base it off of
A
that.
Subway sub.
Yeah, Subway.
Okay, I'm with
A foot long ad.
Yeah. So are you gonna race or you gonna demo? You got somebody that wants to race?
Richard is ready to demo. He wants to really show this off.
Let's do it.
Here we go. There we go.
Nice. I feel like I'm at a drag race. That thing is going nice. Great.
It's a foot-long subway.
Yeah, it's a foot. That's what you should call it, the foot long.
Michael, you guys ready?
Oh, do we have another group that's ready at Silesia? Come on up.
We have another team coming.
We have one more team coming up.
Fantastic.
Okay, great.
So introduce yourselves.
Nice vest, Jerry.
I'm also part of the robotics team. We went for like a more thinner and slick design, so it'll be easier for the robot to like move throughout like wherever we're trying to put it against.
Oh man, I like that design, man. It's a triangle. I love the pulley. Look at that. Nice.
And then we also got some movement on it.
Excellent. I like the pulley. Let's see.
Show it off, Quincy.
And the rest of the team, say hello.
Introduce yourself. Give your name.
Yeah, I'm Michael. I'm Matthew. He's also on robotics.
What robotics vehicle do you all, what robotics competition do you compete in?
FTC.
FTC, okay, first. Yeah, you know, Engineering Tomorrow has competitions as well. You guys got to rock with us next year, right, Constance? Get with us next year. Okay.
All right, are you ready to go, Quincy? Here we go, man.
Hey, nice.
There we go.
Great car. Nice. Great.
Malaysian High School, New Rochelle, New York.
Thanks, Jerry.
Thanks, Jerry. All right. We have some other groups that have their hands raised. Let's see who's ready. Oh, I see this group is ready here. All right, I'm spotlighting you. See? Can you unmute? We can hear you, but it's really loud in there.
Can you hear us better?
Go for it.
Yeah, a little bit.
We did a bigger car and we have 2 batteries in it and here like all the lines mention a word, y'all. Okay.
Great job. Thank you all for showing off those vehicles. Excellent.
All right. I think we have another group at Barnabas. You ladies ready? All right. You can unmute.
Hi. So we didn't use the fan for this one, but it moves pretty fast. Can you show it to him? Sure. Okay. Go ahead. Okay, so it moves really fast. Let me move it back here. Cause
put it on the floor.
On the floor? Okay.
So did you use gears or pulleys?
Okay.
What did you all use? Gears or pulleys?
Ladies, what did you use?
Okay.
Gears or
Ready?
They're just ready to go.
Okay, hold on.
They're ready to go.
do this.
They don't.
Ooh, that is
Yeah.
nice.
That did move.
It moves really fast. Okay. Sorry. Ready?
Nice.
Very nice.
Excellent.
Can you come back? Can you come back to the camera and tell us about your design? Did you use gears
So
or-
the design was kind of complex because at first we weren't gonna like we were gonna flip it over because this is kind of like underneath it, but we found it works better this way. So we just used the tube and put the put it inside. Oh, can you turn it off? It moves pretty fast. Sorry. Like okay, so we have to turn it off for it to stop because it moves like the way it moves when it moves fast, like it goes all over the place. So when we were designing it, it was kind of complicated because we didn't know where to put the engine. Yes, go see.
Excellent. You all, great job. Man, so many great designs today. Another fast design. I know we have a lot of students that would love to kind of share their designs today. You all kick butt. We're willing to take any pictures, any videos that you all have and capture them. Man, I wish we had a way to capture those on social media, man. I mean, you all just really killed it today. I'm gonna just wrap up with some of our just a little bit more information with you, for you all about next steps. So you did such a great job in this lab. I mean, So I got to talk about what are some next steps. If you out of high school, or even while you're in high school, you can be pursuing internships. We're going to talk about that. Also, if you're in high school, you can get like technology certifications. You know, you don't, there's a path to engineering, but you can also get certifications to be involved in the automotive field. There's 2-year degrees out there that you can obtain as well. I know a lot of time we talk about scientists, and a lot of times we talk about engineers, but technicians and technologists, these are the people that actually build the satellites. These are the people that actually assemble the Tesla vehicle. They're very important today as well. They operate the robots that automate the process of building these, making the assembly lines that push out these vehicles to us. They're important today. That's a path, and they make really good money, and they have a lot of fun as well. You may want to take it a step further, become an engineer by going to a 4-year college. And in that regard, you can get involved with like chemistry, developing batteries, or you can get involved with the vehicle engineers, or you can get involved with aerospace, maybe aerodynamics, or material science. How do you make lighter materials? Or again, chemistry. How do you make more efficient solar panels, more efficient batteries? What's the next battery technology if lithium isn't going to work for us? Those are a lot of things that you can pursue. You can even get a master's. Like why get a master's? Why get a graduate degree? You may think, man, I really want to become a really great aerodynamics engineer, or I really want to become an expert in vehicle design. Well, if you want to become an expert, you may go to school just a little bit longer to build up that expertise, okay? So we had questions that you all came up with in the chat about, you know, what do I do as an intern? What are some great internships as a high school student? First, let me just talk briefly about the benefits of internships. One, it's money. I mean, if you're a high school student, you could get paid between $3,000 and $6,000 for 6 weeks of work by doing the same thing you did today. What did you do? You overcame a challenge using the engineering design process. You designed something, you developed it, you tested it, right? You operated it. What else did you do? You had to work in teams, right? That's what we want in interns. We want you to be able to work in teams. Cleanup, you talked about how you failed. You overcame that failure, and then you just kept grinding until you can come up with a solution. Hey, that is really, really good as well. That's all about internship. The benefit of there's money. You get great experience as an intern. I hire plenty of interns, right? But if I know a student has worked on an internship before, I'm going to be more inclined to pick them up. Also, your college application. Imagine saying that you worked at Tesla on your college application. That school is going to want to pick you up. That's also scholarships you'll get. And then finally, it's reputation. Your reputation is built on all the great things that you've done. You've built a great electric vehicle today. That builds your reputation, right? But if you worked on an internship, people are going to know I'm not just thinking about STEM. I'm all in because I've actually worked in this field. So that's great benefits. So what are some opportunities for you? Well, there's great opportunities at GM. GM is one of the great partners here with Engineering Tomorrow. I got to shout out Telva and all she does on our Engineering Tomorrow board. That's a great company. But also companies like Tesla are willing to hire you even as even as high school students. I've even seen in Michigan, Ford has high school internship opportunities for you. How do you do it? It's about who you know, building up that circle of influence. And that it means that you should get involved with programs, like the National Society of Black Engineers, Society of Women Engineers, Society of Mechanical Engineers, Automotive Engineers. That's how you get an opportunity to just build up some partnerships. You know, you get your name out there, but also get access to technologies and internships and people that can vouch for you. Okay. So without further ado, you all did an outstanding job. We have a really, really great speaker for you here today. I want to shout out Kelsey Farr, great engineer. She is the creator of this electric vehicle lab. Did you have fun today? If you have fun today, you want to clap it up for Kelsey Farr and that entire team that just made a lab that I'm absolutely in love with. She has a bachelor's in electrical engineering. That means she is definitely a Sparky out of Notre Dame University. Shout out to the Midwest. And she's building upon that engineering experience and taking it to the next level. How do you become the next tech CEO? Owning your own company? Well, she's mixing in engineering and entrepreneurship. She's not just trying to work for an engineering firm. She's trying to make her own firm. And what she's focused in right now is developing the next new products and technology for electric vehicles, and marketing. What's the marketing strategy as the electric vehicle technology tries to take over gas-powered cars? So without further ado, I want to give a huge shout out and round of applause to Kelsey Farr. She has a really great presentation for you. Hey, Kelsey, how you doing?
Hi, Milton. Hi, everyone. I'm doing well. Thank you so much for having me.
Oh, we're pleased to have
You
you.
guys can hear me, right? You guys can hear me?
Yes, we can hear you. Great to see you as
Perfect.
well.
Good. Yeah, I'm so excited that everyone is so excited about the lab. I was watching you guys show off your different vehicles, and I just love to see all the excitement around it. Just really happy to be here with you guys today. So I have a few slides to share with you, just so you don't have to be looking at me talking the whole time. Let me just make sure this is all good. You guys see my slides fully on the screen?
We can see it, but you have to hit display settings and switch which one we can see. That button, display settings in the top left. If you select that, I think you can switch which screen we see. See display settings.
Is it?
Yeah, I think you're sharing the wrong screen, but there's a
I
little
think
icon. You see
so.
it?
Let me double check.
There's a display settings button in the top middle.
Top middle.
Yep.
Display.
I think the best thing is to stop sharing and reshare again, Kelsey.
Okay.
Yeah.
Okay, thank you.
You're welcome.
Trying to figure it all out. Okay.
You got it.
See.
All good. It's technology. We're all trying to figure it out. We are all trying to
So
figure
I
it out.
should do share screen and then share this one. Okay, let's see if that works.
That's it. You got
Better?
it.
Nice.
Okay, perfect. Okay, well, yes, again, so excited to be with you guys. Thanks for your patience on the technical side, but yeah, really excited. So I wanted to start with a little bit about me, and I guess the way this goes is counterclockwise from the bottom left here, I guess starting at Notre Dame. So I got my undergraduate degree at the University of Notre Dame, and even when I was starting to think about college and think about what I wanted to major in, I had no clue what engineering was. I knew it was something that involved math and science, maybe like coding, maybe doing something like working with your hands, but I didn't really understand how much there is to do in engineering and just how great it is, really until I started to experience it in college. So one of the things, like first thing getting to college that Notre Dame has, and a lot of colleges I think also have this, it's like an intro to engineering class. And in that class, we learned about all different types of engineering: mechanical, electrical, computer engineering, software, aerospace, chemical, really just everything. And we got to do particular activities that expose us to like knowing what the difference between different types of engineering is. And that was really eye-opening to me. And I, from that, kind of decided that electrical was what resonated most with me. But at the same time, and even when I was choosing a college, I was also really interested in like the business aspect of innovation. And that's really what has always been exciting to me. And I think that resonates with a lot of people as well. Just always you're hearing things in the news about like this great new innovation and like this is improving the quality of life in this way. And that for me in general was what my goal was with engineering. So I thought a great way to kind of make sure you have the biggest impact in engineering is also understanding like how can you commercialize technologies and how do you really take those from an idea to something that helps people in their daily lives. So that's kind of where I was coming from and was looking for ways to really implement that. And I was interested in sustainability. So you'll see here, there's a picture of some solar panels. I actually got a minor in energy studies as well. So I was learning about solar power, alternative energies, and just overall sustainability, even aside from an energy perspective, just how do we create the best version of our world looking long term. So electric vehicles, then I was kind of the next natural progression with electrical engineering and an interest in sustainability. And the topic of electric vehicles to me kind of seemed intimidating. It seemed like this really big, incomprehensible topic to me at that time that even as I was starting engineering, just seemed such like a difficult thing to even begin to learn about. So to start out, I looked online on Notre Dame's website and tried to see which professors were doing anything related to electric vehicles with their research, and just ended up talking to one of those professors to see really how do I get started in this field. It seems like such a huge topic and would really love to learn more. And that outreach ended up with me doing research with that professor for 3 semesters, modeling electric vehicles for commercial series hybrids for public city transit buses. So another point about electric vehicles is that there's so many different topics even within electric vehicles. There's passenger cars, there's hybrids, there's buses, just anything that you can think of. And I think all of them kind of have their own place in the industry. So there's so many things you can do with electric vehicles. I think a lot of them that you guys are making today are like fully electric passenger car type vehicles that you're modeling, except for that one long one. That might be more like a bus. I saw that one, that was funny. But yeah, so I started doing research. I also got involved with the Grand Challenge Scholars Program at Notre Dame, which is kind of like a set of challenges that are basically the foremost scientists of our time have decided, like, these are the challenges we think will be most pressing and could have an achievable amount of progress made towards them in the next generation. So there's different chapters at different universities that focus on those problems. And at Notre Dame, I joined that chapter and then started to look at sustainability, particularly through the lens of electric vehicles. And then started doing that research and just looking at like what are the market aspects of electric vehicles? Why might not someone purchase an electric vehicle? Does anyone actually view electric vehicles positively? You know, we're coming out with some research that or news stories that might say that like there are some negative impacts of electric vehicles. So just trying to understand all those different inputs that are coming in and what the market actually looks like. There's a lot of hype around it, especially because it's very new, but really, like, is this something that is worth pursuing? And then just continuing to learn about it. So after I graduated from Notre Dame, I stayed for an extra year and did a master's program in engineering entrepreneurship, which was a really nice combination of all of the engineering things that I have learned, and then kind of taking it a step further and really focusing on market research and commercialization side of that. So I did my capstone project with Ideal Trident, and they had me kind of doing a market analysis for them and seeing, they make different types of like clamp and connector products. So a little bit farther removed from my electrical engineering specific background, but there's all different types of disciplines that go into electric and hybrid vehicles. So I was looking at how different types of connectors would play in the electric vehicle space, which was a completely new perspective. Turns out people care about things like the connectors being really lightweight and easy to apply. I think the lightweight aspect of that is something that you guys also saw in your designs. I know sometimes like the battery is really heavy and then the vehicle can't actually move depending on the design of like how the wheels are and how the weight's distributed. So that's another real world problem, even things as small as like the clamps that connect the different hosing like inside of the vehicle. Those they want to be as lightweight as possible, just to make sure that they're saving weight in every instance that they can. So that was an interesting perspective to have. And then after graduating from my master's program, I moved to Tucson, Arizona, which is where I'm currently coming to you live from. And I work at the Tucson office of Texas Instruments. And I am an automotive industry focused product marketing engineer. So my group in particular does linear voltage regulators. But overall, my job is to kind of create the market strategy for our devices, talk directly to customers, in some cases visit customers on the other side of the world. I just got back from China and was meeting with some of their electric vehicle companies, which was very exciting. The Chinese market for electric vehicles is very up and coming, and there's a lot of competition. So I think there's going to be a lot of changes there in the next few years. And then also taking that feedback from our customers about, like, these are the types of designs they want to be designing in the future, and what types of characteristics do our parts need to have to allow them to then use those parts and create the most efficient system, or the most cost-effective system, the most powerful system that they can. So I think that's probably the most interesting part of my job, is just being able to look at the different trends in the automotive market, even beyond electric vehicles, because I focus beyond electric vehicles as well, and just see what's coming up next, and can we create a product that will solve this problem for the customer. So that has been something that has been really rewarding, and probably my favorite part about my job. So that's a little bit about how I got to where I am. And then advice that I would have for people that are also starting their college career, starting to think about college is, I mean, from what I said, I didn't really know a whole lot. You guys are almost even ahead of where I was at this point if you've done this lab and you've started to learn about these topics. But just continue to ask questions, stay curious. A lot of the work that I've been lucky enough to be involved with has been because I've taken the initiative to reach out, like, to the research professor that I ended up working with, and have just remained curious about asking questions and uncovering new topics that are worthy of exploration. So that's probably the biggest piece of advice that I would have. Just stay curious. So I will go on to the next one. So I wanted to put a little bit of perspective on the growth of the electric vehicle market. From 2021 to 2022, EV sales grew 60%. And that's huge growth for a consumer market to experience. So that means from 2021, 6.5 million vehicles were sold. And then the next year, that number grew to 10.5 million. So still relatively small compared to the number of internal combustion engine vehicles that are being sold, but really the growth here is something that is key to this market really taking off. And I was thinking, well, so why do people really want to purchase an EV, or like, why is there so much interest in them, even if people aren't purchasing one themselves? And one of the main reasons is sustainability. I think electric vehicles are a great way to reduce your environmental impact on kind of like a personal level or family level. They have no tailpipe emissions, as you guys are familiar. There's more to it, obviously, than that, like, where is the electricity source from? And we can get into that a little bit more, but I think that's one of the reasons that people really do adopt electric vehicles is for sustainability reasons. They're also really cool, so that seems to help with the market. Going off of their really cool aspect of that, I think innovation in general is something that people are really focused on. Electric vehicles are interesting because they're new, they're cool. There's features in them that Sometimes internal combustion engine vehicles don't have. I know I've seen like memes about Tesla, like, don't worry, this dog in the car is fine because he has, like, the air is on and everything, like, don't worry about him. So there's a lot of cool things that electric vehicle companies are doing to create interest even beyond just changing the powertrain of the vehicle. That being said, there are still some, I would say, misconceptions about electric vehicles, and it's still a very complex topic. So I wanted to go over some of the main myths about electric vehicles that I think is kind of touched on in the lab content, but also wanted to really draw them out here. So myth number 1, electric vehicles are worse for the climate than gasoline cars because of power plant emissions. And this is actually not true, because I know I had mentioned before, like, there's different factors that relate to where the energy is sourced from for the electric vehicle, things like that. But actually, electric vehicles typically have a smaller carbon footprint than gas cars, even if you account for the electricity used when charging. So taking into account how the vehicles are built, how they run, all of these different aspects, and you can go to this link here as well. The EPA has these myths kind of listed out with some supporting data as well. But actually, electric vehicles have a smaller carbon footprint, despite some of the information that we've seen in recent years coming out with, well, we got to consider the energy usage as well, which is true, but still overall they are more efficient for instead of gas-powered vehicles. And then there's the battery manufacturing aspect of that. Myth number 2, electric vehicles are worse for the climate than gas cars because of battery manufacturing. And again, this study has taken into account the lifetime of electric vehicles. The gas that a car uses is progressively more and more and more, and over the lifetime of that vehicle, it actually outweighs the impact of the battery manufacturing of an electric vehicle. So while the battery manufacturing aspect of electric vehicles may be worse at the first part, like when the vehicle first rolls off the line, electric vehicles might be slightly worse, but over the lifetime of the vehicle, an electric vehicle is actually better for the environment. Myth number 3, an increase in electric vehicles entering the market will collapse the US power grid. And this is one that I hear a lot recently, especially because people are thinking, well, if you have all of these cars and they all need to charge at the same time, then the electric grid can't support that. And it will overload, and then there will be massive power outages, and it just won't be supportable. And that's not necessarily true. So EVs can be charged at off-peak times. So for example, overnight when there's other like houses and electricity that's not being used during the night. So like you're not going to have the lights on in your house overnight for the most part. And during those times, the grid has a lot more energy that it can provide because that energy isn't going to powering things like people's homes. So EVs can be charged easily during those times if you really wanted to avoid it. But I would say, especially at this point, plugging in your electric vehicle to the charger in your garage, for example, or one that you find near a gas station is not going to really cause any impact to the electric grid. In the future, it's definitely something we should be thinking about. I don't want to say that it's just no problem, but really trying to assess the impact of electric vehicles and the realistic impact they can have on the grid and things we can do to mitigate that. And EV charging actually consumes less electricity than water and air conditioning in the typical US home in 2020. So even if you're comparing an electric vehicle charging in your house versus the electricity or air conditioning that's typically running, it's still less than that demand. So it's not like a gigantic demand all at once. It's definitely something that the grid is designed to support. There's also vehicle to grid charging, where There might be extra energy that the battery has in it, and let's say the person who owns that car says, oh, we actually don't need all of that charge right now, like I'm only driving like 5 miles to work tomorrow. You could actually give that energy then back to the grid. It works both ways. So it's a really interesting area of innovation here, is having that power flow both ways. Myth number 4, there's nowhere to charge. In fact, there are over 57,000 stations in the US that are available to the public. So this is not including the stations that people might put up in their garage after they get an electric vehicle. These are the ones that you can kind of find like at a rest stop or at a gas station or just in a parking lot, for example. So this is significantly lower than the gas stations in the US. So here's a comparison with the number of gas stations in the US. And I'm not trying to say that there are as many electric vehicle charging stations as gas stations. It's not true. But I mean, I think a lot of us have the experience where we're like sitting at a red light and then we realize that there's 3 different gas stations at the corner that we're stopped at. And if that's the case, like a lot of these gas stations might actually not be necessary to support the infrastructure of cars at this point. There's just so many. It's almost like we don't need all of them is kind of how I think about it. And the charging stations, while they are kind of like interspersed throughout the US, I would say that there are certain areas where they're more prevalent. So the decision to purchase an electric vehicle might be dependent on if you're in an area that has more access to charging infrastructure, because I do think this is one area where we can improve the visibility of charging infrastructure, like the ease of being able to find them, and just really trying to improve that. So while there are places to charge, still room for improvement is what I would say. Another point here, range anxiety. Electric vehicles don't have enough range to handle daily travel demands. In fact, electric vehicle range is actually more than enough for the typical daily use in the US. So average car usage for a US household is 50 miles per day. I definitely don't drive anywhere near that. And then actually 85% of US households travel under 100 miles a day. So average number to give you like half of people travel less than 50 miles a day, half of people travel more than 50 miles a day. But actually, if you look at it just slightly up at 100 miles a day, 85% of US households fall within this range. So most electric vehicle models at this point go above 200 miles of charge on a fully charged battery, and then all new models travel with more than 100 miles on a single charge. So if you're just using this for day-to-day, like typical vehicle use, this is more than enough for your needs. And people will have like a charging station in their garage. Charging overnight is definitely something that is very accessible. And then you're able to be ready to go the next day. So it becomes a different conversation if you're talking about a road trip, because I know that there's a lot of you thinking right now, well, what happens if you are like driving across the state and then you have to wait to charge your vehicle and it takes longer than filling up your tank of gas, which is completely true at this point, and I think is another area that we need to improve at an industry level to really help people adopt electric vehicles, to really make them work for the consumer, because it's not like we should have consumers kind of like change their expectations to adopt electric vehicles, because in reality, that's just not going to work. Public opinion is crucial for success of a new technology, especially, and you want electric vehicles to match the expectations that people already have of the cars that they have. You have to make something that is at least as good as what they're currently using if you want them to switch. So that is still something that I think can be improved. So I just wanted to kind of pause here and talk about some electric vehicle trends, maybe some news that people have seen, because there were a couple questions about like batteries catching on fire and things like that, that I think people hear these kinds of things and then they get a little bit nervous about electric vehicles, which is understandable. You don't want your car to catch on fire. So, but I wanted to address that one, I guess. First would be electric vehicles. They use typically at this point lithium-ion batteries. And lithium-ion batteries, the reason, like when you hear about a car catching on fire, the reason that happens is an issue called thermal runaway, which is if the battery cells in the vehicle aren't balanced completely, sometimes it could happen that batteries cells within the pack short together and then heat up to an extreme amount. That being said, that happening is much less common than an internal combustion engine vehicle catching on fire. Looking at like the statistics and prevalence of it happening, it is not something that is really a concern. And in fact, on the engineering side, that is something that is paid especially attention to, because they have these really robust battery management systems where each battery cell is charged at the same rate and monitored, and they have sensors and different software in there to really just always be looking at the state of charge of the battery. And then even then, there's additional safety measures implemented to make sure that the vehicle, even if something were to happen, like a fault condition, then the vehicle fails into like a safe mode rather than having a fire or something. So much less relevant, I guess, than you would expect, given a lot of the hype around it. But electric vehicles are extremely safe and have a lot of different engineering checks and measures in place to prevent those kinds of issues. And then another question was, how does the modeling of electric cars impact their construction, and what manufacturing or design changes have occurred to push for more electric vehicles? So electric vehicles, really like every discipline of engineering is used, I would say, to a certain extent. You have the mechanical engineers who are designing the outside of the vehicle, trying to make it more aerodynamic and energy efficient in that way to like reduce the wind resistance, make it a more efficient vehicle. Then there's electrical engineers who are designing the interior of the system, trying to everything from like the powertrain, trying to make that as efficient and safe as possible, to the systems that have like the different cameras and sensors on the car for advanced driver assistance systems, trying to help you drive as safely as possible. The display in front, that's all electrical engineering. But then things like the battery itself would be chemical engineering. So chemical engineers work with the battery chemistry and try to improve the efficiency and weight of the battery and just try to create a more efficient system. So some of the important considerations for new vehicles, I think new battery technology is on the rise with solid state batteries. So they're lighter, more efficient versions of lithium-ion batteries, and I have an extra slide about that a little bit later. But that's one of the areas of like chemical engineering in electric vehicles that I think is really exciting. So you might be wondering then, why don't more people buy EVs if they're as safe as I'm saying they are, if they're as safe as the research says they are, they're good for the environment, then why don't people buy them? And I think one of the major reasons is range anxiety. So feeling like you're not going to have access to a charging station, or the impression that the battery capacity isn't going to be enough to get you through your day-to-day, because you don't want to be stranded, you don't want to be looking down the road at a tumbleweed and no charging infrastructure for you to actually get anywhere with your vehicle, because despite how nice it is, if it isn't charged, then you're not going to be able to go anywhere. And then another thing might be, you've heard stories about the battery catching on fire. People are concerned about the safety for that reason. And then another reason might be cost. A Tesla is an expensive vehicle. It's more expensive than, I would say, an average car. That being said, there are more cost-effective electric vehicles at this point. A lot of that cost is linked to battery range directly, because a lot of the battery cost is what impacts the cost of the vehicle. But I mean, I've addressed these issues now, and it seems like electric vehicles are, like, they're safe, they can fulfill kind of like the basic requirements of a vehicle that you would expect to be able to use day to day. But the reason why some people then still aren't adopting them is because public perception really is make or break for new technology. So even if these types of concerns aren't exactly true, it doesn't really matter whether they're true or not if it's what people are thinking. So if someone says, like, oh, I'm not going to be able to find a charging station, they're not going to look into it more, and they're not going to buy an electric vehicle. So I think looking at how we can change public perception of electric vehicles and try to inform people better is going to be one of the keys to actually adopting these on a more widespread scale. And then a few more notes about electric vehicles and the evolving market. So a lot of you guys were interested about new technology trends and things like that about electric vehicles, and that's exactly what I'm interested in as well, so I'm happy to share that with you. So one of the things I had mentioned was the solid-state batteries. So currently lithium-ion batteries are used. They're the best in their class for what we currently have. They're much lighter and more energy dense than things that were used in the past, like nickel metal hydride and lead acid type battery compositions. They're still a little bit too heavy and don't have as much of a battery capacity as people would ideally like, I would say. Solid state batteries solve a lot of those issues. So let's just see here. I have this graphic here. But just to show the difference between lithium-ion battery and solid-state battery is really just the inside here. This is a solid electrolyte in the solid-state battery, where this is kind of like it's almost like a goo in the lithium-ion battery, and for that reason, this is much heavier and not as energy dense as the solid-state battery. So we had talked about before, weight can sometimes be an issue, and that is solved with the solid-state battery. You can also charge a solid-state battery much faster, 10 to 15 minutes for 80% charge, which then eliminates that concern of you kind of like waiting on the side of the road if you're on a road trip for 2 hours trying to charge your vehicle. Solid-state batteries will also solve that problem. They also have a 5 times longer life cycle than lithium-ion batteries. So over time, solid-state batteries last a longer number of cycles. So like charging and discharging cycles, they have a longer lifetime. They also retain charge better in cold weather. So that's another concern people have with electric vehicles, is if you're driving in like somewhere up north in the US, sometimes your battery performance with lithium ion is degraded and you don't have as many miles on a full charge. That problem is also solved with solid state batteries, and they are also safer. So they don't have this issue of thermal runaway. So despite us managing it right now, I would say, with different engineering and monitoring systems, it's obviously much better to just eliminate that as a possibility at all. So solid state batteries do that as well. So it seems like solid state batteries solve all of these problems, so you might be wondering why you haven't heard more about them at this point. And it's just really because the technology needs more development before it's in widespread use. So the main like technical limitation of solid state batteries right now is there's these, they're called dendrites that are formed between the anode and the cathode, and those can cause shorting of the battery, which then causes the battery to not work or retain any charge at all. So that is the main issue with solid state batteries right now. That being said, there's a lot of investment in this area, and I would say probably within the next decade, solid state batteries will be ready for use in electric vehicles, and there's going to be like that, I think, will be the last key obstacle preventing EV sales from like skyrocketing. So once that happens, I really think we're going to see this market take off even more than it has. So that was something that I wanted to share with you guys as an interesting thing coming for the future. I think that addresses a lot of the questions that you guys had, like about cold, exciting innovations, things like that. Yeah, and I think that will help with charging speeds a lot, especially. It's just a really interesting area. So I guess that's where I'll leave that, is solid state batteries are the next thing.
Oh, wow.
But then I also...
Oh, go ahead. Go ahead, Kelsey.
Yeah. So then I also wanted to just show briefly places where engineers might have more or less influence on if EVs are adopted in the future. So engineers can control some of those things, but there are some things that obviously we cannot control everything. But I think knowing what factors will actually impact whether someone buys an electric vehicle can help us as engineers, because we then know how do I design an electric vehicle that people are going to buy, and is it worth investing in like making this part of electric vehicles better if that, like, is that something that people care about? So just knowing where to direct your energy as an engineer and knowing what people care about, so you can then innovate and continue driving that progress forward. So engineers can control things like the vehicle features. They can control the driving experience, a lot of the like cool features of cars in the display system, different radar, camera, self-driving features that are common, I would say, becoming more common. Those are things that engineers can do. Battery range and capacity, chemical engineers are working on that. That's a huge area for solid state batteries. Safety, the monitoring of the different safety systems in the vehicle, preventing things like fires. Engineers have influence on that. To an extent, I think engineers also can help reduce the cost of the system, designing more efficiently, and then also charging infrastructure availability. Engineers can work on novel approaches to charging infrastructure, as well as like cost reduction type engineering, and then that can be implemented more widely. So limited influence here, and then not really as much influence at all on like public opinion or government incentives. Those are things that are more out of engineers' control, with the exception being like maybe some engineers who do work on public policy, but that is an exception, I would say, more so. But yeah, just really understanding how all these different factors play into one another. And also realizing this is not an exhaustive list. There's definitely more factors. These are, I think, some of the key ones driving, like, why do people choose to or choose not to buy an electric vehicle. But I think understanding these really gives us a much better chance of actually affecting positive change with electric vehicles. So kind of to wrap that up, I just wanted to say, as engineers, approaching a complex problem like electric vehicles, electric vehicle adoption, approaching that with an open mind and trying to understand all the nuances and having a holistic view of the market is so crucial because all these different factors play into one another, and you can't have innovation with like just software engineering. You can't have innovation with just electrical engineering. You can't have innovation with just mechanical engineering. It's really when all those things come together, and even with things like government, like public policy, advertising, and how we can kind of shift public opinion depending on how people view electric vehicles. All those things come together and make a complex problem like this what it is, and then just understanding that sets us up for best success and progress. I think this also goes along nicely with one of the reasons that diversity is so important in engineering, is that if you have a diverse set of engineers who look different, who come from different backgrounds, they will be looking at the problem from a different perspective than you. The most important thing I would say in engineering, just overall, is having an open mind and making sure that you are listening to the experiences of other people, because really the experience that a customer has, for example, that is going to directly impact whether or not they buy your product, whether it's an electric vehicle or anything. They're telling you like, oh, I want this, this, and this, or I don't like this. If you have those insights, you're able to then like make a product for them that is the best fit. Similarly with diversity in engineering, you might have people on your team that have those same opinions, that have had those experiences, and you really need to make sure that you're like putting your own perspective forward, but also listening to diverse groups of people on your team, customers, whatever it is, and actually being able to take all those insights together and come out with the best possible solution, knowing that you have kind of looked at it from multiple different angles. Okay, so I would say that's it for the long speech portion of my presentation. So I just wanted to say thank you guys so much for having me. It's really great to see, again, all the excitement with the lab, and just really excited to share this topic with you, especially considering all of the different things that go into it. And I've been looking at this for years now, and I still definitely don't know everything. So I just wanted to say there's still a lot more work to be done, and you guys are the next generation here. So even if you don't end up working on specifically electric vehicles, I really hope that you consider engineering as a path that could be for you, and just really do what makes you the happiest there. So I hope that you are now seeing that engineering could potentially be a career path for you if you didn't before.
Oh, thank you so much, Kelsey. And could we just, give a round of applause again before we ask some questions? That was a great presentation, great background, great story. You've done so much just to be so early in your career. It's really, really awesome. I love where you landed.
Wow.
That last part of the conversation that you talked about, it's like people don't appreciate at the middle of the engineering design process wheel, it's the customer. Right? I mean, you don't have a product without a customer, without driving their needs. Could you talk a little, driving towards their needs, could you talk a little bit about, how your mind shifted at some point where you said, hey, I don't just want to be an engineer. I want to focus on entrepreneurship as well.
Mm-hmm. Yes, yeah. So I was interested in my mind when I was starting college, either engineering or business. And then when I started with engineering, I realized, well, actually, there is a good amount of this that overlaps with business, because again, like you said, I came to the realization that you can't really design anything if you don't get customer feedback, and if you aren't designing for something. You have to think about what your goal is. If you just are designing something in a a room and you're never talking to anyone. It's like you could make something great, but if it doesn't solve a real problem that people have, then what's the point? So yeah, so that's something that I realized, and then I think taking a lot of very like interdisciplinary focused classes in college helped me realize like there's this public policy aspect of engineering electric vehicles that like you might be incentivized to buy an electric vehicle for some reason. You might have this type of restriction if you are a car manufacturer, and all of those different things impact what type of engineering product comes out of it at the end.
Yeah, there's great answer. There's still not a lot of females in the STEM space. I think there's even less in the automotive space. So what made you say, hey, I want to be down with cars. I want to get down with electric vehicles.
Yes, and it is funny because I've never really been like a car person. And this became abundantly clear to me when I interned with Ford when I was after my junior year in college, and there were a lot of like car people at Ford. Like, I mean, it makes sense. It's a car company.
Yeah.
I was interested more in like combining sustainability and engineering and really what was the next big thing in that space that matched kind of like my skill set that I was thinking I was going to have when I graduated, and just trying to see what really is the best place to innovate and following that trend. So for me, that's why I ended up with electric vehicles, the sustainability aspect of it especially. But yeah, I'm not really like a huge car person other than that, just like the engineering side of cars, but would never be a car collector or anything.
Got it. So let's say you get to start your own company, like you're the CEO, your own firm. What would you want to do?
Oh wow, that is a great question. It's interesting because I think it would probably be something related to like the interplay of like electric vehicles and market perception, kind of like market research, trying to understand really what people think about electric vehicles. That's been like my favorite part of the job that I have, is trying to gauge customers' opinion, public opinion, and then seeing how that impacts things. But I think if I were to kind of like go out on my own, I would probably do something around like aggregating that type of data and then informing different automotive companies so then they could be most informed about what the next trend is and what consumers care about.
Awesome. I heard a lot of research. I heard some data analysis, some data science in there, some marketing all involved in that, and some consulting. People don't appreciate that. There's consulting in the engineering space as well. That's really, really good. I want to know another question. I got plenty of questions for you. And if folks want to put questions in the chat, you can do that. How did you get involved with Engineering Tomorrow? Like, you developed this great lab. How did you get involved with Engineering Tomorrow, and how did it shape your collegiate and career path?
Yeah. So I was working on the Grand Challenge Scholars Program at Notre Dame, looking at the different aspects of like research, market, the different things about electric vehicles, and then I actually had one of you guys, Megan Barrett, reach out to me because she had talked to one of the professors who was the director of Grand Challenge Scholars Program, and Engineering Tomorrow was wanting to develop electric vehicles lab of some sort. So my interests at that point and what I was working on, especially the way I was looking at the problem holistically, like high level, was, I think, exactly aligning with what Engineering Tomorrow wanted at that time. So our timelines intersected, which was very fortunate. And it also has been a just really rewarding experience to me, to not only like create the lab and share knowledge with so many countless people now who have seen it, with you guys today, but I also served as a college mentor during my time in college and was able to see, how different students interact with not even just the electric vehicles lab, but with labs in general, to see some of the questions, that different students come up with. And it is just so interesting just to see how smart you guys are. You always ask the best questions. It is just so amazing to me. It's things that I never was even like, nothing was on my radar to that extent when I was in high school. And you guys just really are great with questions. So
Yeah, these students are outstanding, and it's amazing. You develop this lab, you give them a problem. Don't give them too much, right? You don't want to tell them too much how to do it, and then they just create and ideate things you never imagined. They are absolutely killing it. And I'll also shout out Megan Barrett. She just finds some outstanding interns. I mean, Engineer Tomorrow definitely has some of the best mentors and college students out there for sure. And we talked about internships before, but if you want a great internship, you get a chance to work with just world-class engineers when you work here at Engineer Tomorrow as an intern or a mentor. So we talk a lot about work. What do you do when you're not working?
yes, great question. Although we've talked about work forever. Yeah, so I'm originally from the Midwest. I grew up in Cleveland, Ohio, and then went to Notre Dame in Indiana. But now I live in Tucson, Arizona, which is like way, way different from where I grew up. And I think being in Cleveland, there's a lot of green spaces, despite the perception some people might have of it. Cleveland is a great city. So there's a lot of green spaces. There's this area called the Metro Parks. There's like waterfalls and trails for you to go around. And I really liked that part of Cleveland. So then when I came to Tucson, I realized that there's even more to do here. There's hiking. There's just like, if I look out to my left right now, there's a window that just looks at the Santa Catalina Mountains. So it's just like, there's so much to do outside in Tucson. There's a lot of different local restaurants to try as well. The Mexican food here is great. So I would just say like kind of like being outside, trying different types of new food, and just really just going out and relaxing. Yeah.
That is cool. I'll take us back to the other side a little bit, get back to the technology. Outside of battery technology, which we know is critical for electric vehicles, like what is another technological advancement that's needed for EVs to kind of push more on internal combustion engines?
Yeah, so I do think the battery technology aspect of it is like majority, like that will honestly take care of the majority of like a lot of the stopping points for people to adopt them. But there's always innovation going on even outside of that. Like there's different automotive systems that can be used for safety, things like advanced driver assistance systems with different sensors and cameras are making self-driving seem more and more like it could be happening. Like I know my car, it's a 2020 model and it has adaptive cruise control, like with lane centering, so it can just see where the lanes of the road are and also where the car is in front of you and adjust your speed and position based on those factors. So like if I'm driving on the highway with that on, I basically am in a self-driving car. It just needs to have like sense that my hands are on the wheel. So then that's not something that's unique to electric vehicles. I drive a hybrid, for example. But that I think is another really exciting innovation in the automotive space is the push towards self-driving, and we could have a whole nother session on that and some of the limitations and things that need to happen before that's completely safe and really ready to roll out. But it's a huge area for innovation right now.
That's a great segue because that was one of the big questions that we got from students. Like, what's some things we need to do in order to let self-driving cars and the infusement of artificial intelligence and driving cars to make that a reality, what are some boundaries or laws or rules we need to put in place?
Yeah, so there's multiple levels of self-driving cars. There's like, for example, the version of mine where it has to have an input from the driver. It has to like see that you're looking at the road. There's some that operate within like geo-fenced areas where like the road conditions are good enough for the camera to see that the lines are there, for example. I think rolling out self-driving cars slowly and in areas where it makes sense, like given the level of technology we have available. So I wouldn't just kind of like set a self-driving car loose like in the middle of a dirt field or something, because it's not gonna like know what to do. It's just gonna just start driving until it like sees an obstacle or something. But in areas where like we do have the speed limit signs well marked and the car can read those, and like has the GPS signal availability and can see the lines of the road, I think like if we have them on the road in limited situations like that, they are very safe. Things like LiDAR, it allows you, it's like the spinning things you see on top of self-driving cars. It has like a really precise level of detail when it sees the surroundings of the car. So there's definitely a lot more to do, but I think that rolling things out slowly based on what we have available is a great first step.
Great, excellent. Well, we thank you again so much for this time that you spent with us here. Thank you for taking your time out to talk to us about electric vehicles. We thank you so much for creating a great lab. I mean, you have to know hundreds of thousands of students have been impacted by this electric vehicle lab. One of the favorite labs, if not the favorite lab of engineering tomorrow, it's my favorite for sure, because I just tried to build a whole competition around it. So I wanted to just highlight a few really good things about this presentation before we wrapped up, and some great nuggets that I caught from you. I caught this, Kelsey Farr, the right parts, because you're in automotive engineering. You got to have the right parts. One, you just talked about creating the best version of our world. That's what you can do with engineering, everybody. You can create the best version of our world, but you got to take initiative. You know, I love how you kind of charted your own path. You talk to college, you talk to advisors at school to get involved with them. You remain curious by asking questions and seeking other people's experience. You have a mindset where you're not just going to work for a company, you want to own your own. And I know in the next 5 years, you're probably going to be dominating the field. And then finally, just having that open mind and that holistic view. It's not just what we're designing and developing. Customers matter. The market matters. You know, all the different parts that work together, all of that stuff matters. So thank you so much. Great presentation. Let's give it up for Kelsey Farr one more time. Outstanding job. Let's give it up for our entire ET team. Again, you all killed it. Love working with you all. And our on-site engineers in the places to be. DC, New York, just all over the place. Highlighting this again, we got an electric vehicle challenge coming up, UMD May 18th. Scan that QR code if you want to get down with us, which our goal is to have 100 students compete in an electric vehicle. You already have an electric vehicle. So if you're here, you're a step ahead of the game. And that's it. I want to just say thank you all so much for a great, great day. I'm going to hand it back over to Monica to talk about next steps. You all killed it today. Thanks.
Well, thank you to Kelsey, but thank you to Milton for leading such a fantastic EV day. And thank you to our teachers and students who were here engaged and designing some amazing EVs on this Earth Day. Don't forget, we have other events coming up. Please check us out on our website. And don't forget to complete your teacher and student exit tickets. We can't wait to see you for the next one. Fantastic job, everybody. Have a great day.